Right, let us take a look at question 1 from the DBE 2024 November question paper. So now the first question 1.1.1, the question says solve for x. So now let us solve for x there. The question goes by x into x minus 3 is equivalent to 0. So when you have a question of this particular nature, a lot of learners tend to waste time by multiplying, and then after multiplying they are going to factorize. Already the question has been factorized for you. All you need to do is to know that in order for two numbers a multiplied by b to give you 0, either a is 0 or b is 0. In order for two numbers, in order for you to multiply two numbers and get 0, it means that one of them must be 0. In this case, we have a similar case. For these two, for this one and this one to give you 0, either x is 0 or x minus 3 is equivalent to 0. And then when you continue with this one, x is equals to 3. That's how you solve the question. Now moving on to the second one, our question here says that solve for x, and then there is something that I want you to take a look at right here, which is this part right here. So whenever you come across a question that says correct your answer to 2 decimal places, this right here is an indication that you must make use of the so-called quadratic formula. So whenever you come across this is an indication that you must make use of the so-called quadratic formula. So now let us solve it. We have our question as 2x squared plus 1 is equals to 4x. Before we can apply the quadratic formula, we must first put our equation in a standard form. Now, what is to put the equation in a standard form? It is to take everything to one side and leave 0 on the other side. So now let us put it in a standard form. This is going to be 2x squared minus 4x plus 1 is equals to 0. Now, when you have your equation in this particular format, you can identify your a. So the coefficient of x squared is our a, the coefficient of x is our b, and then lastly the constant is our c. So now let us write down our quadratic formula. Make sure that you know it by heart. It's minus b plus minus the square root of b squared minus 4ac all over 2a. So now let us go on with our question. After writing down the quadratic formula, now you substitute. So to avoid making mistakes, wherever I see the letters, I open the brackets. It was b here, I open the bracket. It was a here, open brackets. It was a here, open brackets. And then from here, I substitute. In the place of b, I put in negative 4. In the place of a, I put in 2. And then lastly, in the place of c, I put in 1. And then I go to my calculator, I press my calculator. When I press my calculator, this is what I get. I get 1,71 and 0 and 0,29. This is our answers for 1.1.2. Now let us continue with our question. I move on now to question 1.1.3. Question 1.1.3, we call it a quadratic inequality. So we have x squared minus 2x minus 3 is greater than 0. So whenever I see this, I know that this implies an inequality. So now this is how I solve this particular equation. When I have something is greater than 0, this implies positive. This is where I start. Something greater than 0, it implies positive. This is where I start. From here, I factorize. Now how do I factorize? I look for two numbers that when I multiply they give me -3, and when I add they give me -2. So now what are those two numbers? And that is because the coefficient of x squared is 1. So what are those two numbers? Those two numbers are -3, or those two numbers are 3 and 1. And then you must remember when you get here that the bigger number takes the sign of the middle term. The middle term is -2. The middle term is -2, so the bigger number takes the sign of the middle term. And what determines the sign here is the fact is that this sign here multiplied by this sign here, it must give me this sign right there. So the only sign that will give me negative, it's when I have a negative and a positive. So this is the factorization. From the factorization, I write down the critical values. Now the critical values are the values that I would get if I was to solve for x here, if this equation here was equivalent to 0. So I would get 3 and -1. And then from here, I draw my graph. So drawing the graph, how will the graph look? Let me first start with the smallest critical value, and then I'll continue to the largest critical value. How would my graph look? My graph would be concave up. Why would the graph be concave up? Because the coefficient of x squared to begin with here was positive. So if the coefficient of x squared is positive, if your a is positive, your graph will always be concave up. And then if your a is negative, your graph will be concave down. So it's minus here, plus here, plus here. And then now we get to the answer. The question was saying, where is the graph greater than 0? In other words, where is the graph positive? And our graph is positive here and here. Now, how do I represent this mathematically? This is where x is less than -1. And then here, this is where x is greater than 3. We move on to question 1.1.4. Question 1.1.4 goes as follows: 2 to the power of 2x. Let me copy it down. Okay, here is our question. 2 to the power of 2x minus 2 to the power of x plus 2 minus 32 is equivalent to 0. So before I can try to solve it, let me quickly break it down. So when I break it down, this is going to be 2. This is 2 to the power of 2x minus 2 to the power of x multiplied by 2 to the power of 2 minus 32 is equivalent to 0. So now the reason behind this is because when bases are the same with multiplication, we add the exponent. So what we are doing here is the reverse of that. And then 2 to the power of 2x can be written as 2 to the power of x all squared. And then the 4 right at 2 to the power of 2 can be written as 4 multiplied by 2 to the power of x minus 32 is equivalent to 0. When I get to this stage, I say let k be equal to 2 to the power of x, meaning that wherever I see 2 to the power of x, I replace it by k. So this is going to be k squared minus 4 times k minus 32 is equivalent to 0. And then it goes back to that thing that we spoke about. How do you factorize? Because our coefficient of k squared here is 1, I'm going to look for two numbers that when I multiply, they give me -32, and when I add, they give me -4. So how do I go about doing that? I open two brackets. Factors of k squared is k and k. And then the two numbers that when I multiply, they give me 32. But when I add, they give me -4. 8 and 4. 8 and 4. And you must remember that the bigger number always takes the sign of the middle term. And then what determines the last term is that the 2, when I multiply them, they should give me this one. So which sign here, which sign will I multiply by negative to give me negative? It can only be positive. So when I multiply these two, they give me this. When I add them, they give me that one, meaning that k is equals to 8 or k is equivalent to negative 4. But I'm not done. The question had said that I must solve for x, not for k. So it means that k, we know that is equals to 2 to the power of x. So in order for me to solve here, I know that the laws of exponents always say when bases are the same. So I cannot be able to solve for x here, which is at the exponent, if the bases are not the same. So it's going to be 2 to the power of x is equals to 2 to the power of 3, meaning that x is equivalent to 3. And then the second one, 2 to the power of x is equals to negative 4. And we know that this is an exponential graph, and the exponential graph is always above 0, meaning that there will never be a time where 2 to the power of x is equivalent to negative 4. So there is no solution for this one. Now let us move on to question 1.1.5. Let us copy down the question. Question 1.1.5 goes as follows. Minus 2. This is our question 1.1.5. So we call this set equations. Why do we call them set equations? Because these are equations that involve the square root. So the first step of solving sets, it is to isolate the square root. So what is to isolate the square root? It is to put the square root aside, meaning that I'm going to write my equation in this particular format: minus 2x plus 4. I take the x to the other side. It was negative. When it goes to the other side, is positive. Now the square root is 1 on one side alone. Everything else is on the other side. Second step, it is to square both sides. I square the left hand side and I also square the right hand side. When I square the left hand side, I am left with minus 2x plus 4. And the right hand side, whenever you square a binomial, you get a trinomial. Or simply, I can say 2 plus x into 2 plus x, because you know that square means you multiply the number by itself 2 times. So this is going to be minus 2x plus 4. This one, we're going to multiply this one by this one, it gives you 4. You multiply this one by this one, it gives you plus 2x. You multiply this one by this one, it gives you plus 2x again. You multiply the last ones and they give you positive x squared. Now let us simplify the right hand side. So this is x squared. 2x plus 2x, they give me 4x. I'm left with 4 here. So I put the equation in a standard form. So I leave 0 on one side, x squared. I take negative 2 to the other side, 4x plus negative 2. 4x plus this 2, when it goes to the other side, it becomes 6x. 4 minus 4 is 0. So what I see here, I see x here, I see x here, meaning that x is a common vector. So I'm left with x plus 6. This times this is x squared, this one times this is 6x. So this is a sign that I factorized correctly. So when solving here, I know that x is going to be equals to 0, or x plus 6 is going to be equals to 0, meaning that x is negative 6. But I am not done yet. When dealing with set equations, at the end you need to check. So how do you check, ladies and gentlemen? When x is equals to, because I've got two values, I'm going to take a look at the left hand side. When x is equals to 0, I take a look at what happens to the left hand side. So the left hand side, when I put in 0, is going to be the square root of minus 2 into 0 plus 4 minus 0. So this is equals to 2, and the right hand side, it was given that it is equivalent to 2. So this is the correct solution. Now let us take a look at what happens when x is equals to negative 6. So the left hand side is going to be minus 2 into minus 6 plus 4 minus into minus 6. So let's solve it. Negative 6 times negative 2 is 12. 12 plus that is 16. The square root of 16 is 4. So the square root of 16 is 4 plus 6. This is 10. And the right hand side, as it was given, is 2. So these two are not equal. The left hand side and the right hand side are not equal. So meaning that the answer of x is equals to negative 6 is not applicable. So we scratch it out. Then we move on to the last question here, which is the simultaneous equation, question 1.2. So these are our equations from the simultaneous equation. So this is our equation 1 and this is our equation 2. So to solve this simultaneous equation, I must form the third equation. So I take a look at equation 1 and take a look at equation 2 and I check. Normally what I check for the equation that does not have the squared, or that is easy to manipulate. So taking a look at this equation and this one, it is easier for me to make y the subject of the formula from this equation rather than this one. So I'm going to, from equation 1, I make y the subject of the formula. So meaning that I take this 2x to the other side. So it was positive. When it goes to the other side, it becomes negative. So I call this my equation 3. From here, I substitute equation 3 into equation 2. Now, what does that mean? It means that I now go to equation 2, where there was y, I replace that y with 3 minus 2x. So this was our equation. It was y here, I'm going to replace it by 3 minus 2x. It was y also here, so I'm going to replace it by 3 minus 2x. So I start by opening brackets where there was y plus x. Here it was y. I open brackets. On the other side we have 2. So I replace y with 3 minus 2x. It was y here. I put in 3 minus 2x. And then from here, whenever you square a binomial, you get a trinomial, or you must remember that a number squared, it's that number by itself 2 times, meaning that this is going to be 3 minus 2x multiplied by 3 minus 2x. And then let me continue with this one exactly as it is. From here, we multiply. This is FOIL. 3 multiplied by 3, it's equivalent to 9. 3 times negative 2 is minus 6x. This one times this one, minus 6x as well. Lastly, this one times this one. Negative times negative is positive. 2 times 2 is 4. X times x is x squared. X times 3 plus 3x. X times negative 2 minus 2x squared. I take this 2 to the other side, it becomes negative. From here, I deal with the like terms. So now let us highlight our like terms. 4x squared goes hand in hand with minus 2x squared. So I add them. 4x squared minus 2x squared, they give me 2x squared. Another like terms that we have there, minus 6x minus 6x plus 3x. Minus 6x minus 6x is minus 12. Minus 12 plus 3 gives me minus 9. And then lastly, we have 9 and 2. So 9 minus 2 is nothing much but 7. And then I get to this one. You either factorize, but remember that if you cannot factorize, the easier way it is to make use of the quadratic formula. So the two numbers that give me 7 is 7 and 1. we're going to have negative here, meaning that the value of x is 7 over 2, or the value of x is 1. But the question had said we must solve for x and y simultaneously. So we know that when x is equal to 7 over 2, y will be equal to 3 minus 2x. In this case, x is that. This one and this one cancel each other out. I'm left with 3 minus 7, which is negative 4. Or y is equal to 3 minus 2 into 1. This gives me 1. This is the end of our video. Thank you so much. See you in the next video.